Good morning, everybody. Happy Thursday. We're jumping into our last video of the unit, and this one is a review. Okay, so we're done the linear relations unit. We're wrapping that up. Little review today, and then you'll write the summative assessment unit exam tomorrow. That'll be on Friday. So similar to the last couple of units, I'm going to post a review package, just a PDF that you can just copy down. If you have the printer at home, you can print it. If not, just write down your work and work through it. And what I'm going to do is go through kind of some of the questions that I think are important, and then leave the rest for you to do as some studying. So with that said, let's jump into the review package. Here we are in the review package. So again, this is I posted with the lesson, just a PDF where maybe you have a printer at home, you can print it off. But more likely, just write down some questions on some blank paper and work through it with me. So I'm going to go through some of the questions, and then I'll leave the rest for you to study to get ready for that summit assignment tomorrow. Question number 1. Write the equation of the graph shown in slope-intercept form. And it asked me to kind of walk through a few things. So first thing it asked for the slope. If I'm going to find slope, I need to find 2 good points on my graph. Maybe I notice that's a really good point, and then that's a really good point. And I know slope I can always count as rise over run. To get from those points, I go up 1, so a rise of 1, a run of 3. My slope equals 1/3. Okay. Y-intercept, well, that's where I cross the y-axis. The y-axis being the axis that goes straight up and down. I already actually labeled that point. 0, -1, which tells me I have a b value of -1. We'll come back to that in a sec. The x-intercept, that one's over here, 3, 0. But then when I go to find the equation, I don't actually care about the x-intercept. The x-intercept's good. I can label it on the graph, or maybe I find it algebraically. But the equation of a line, at least one version, is y equals mx plus b. So I'm looking for the slope, and I'm looking for the y-intercept. Not the x-intercept, the y-intercept. So my equation would be 1/3 x, that's my slope, minus 1. My b value is -1. Okay, so y equals mx plus b, slope-intercept form is super useful, and really we use that one quite a lot. All right, next one. Graph y equals 1/5 x minus 4. This is the opposite. Here's the equation in y equals mx plus b. Can I put it on a graph? Well, yeah, because if this is slope-intercept form, it tells me the slope, that's 1/5, and b value of -4, that gives me the point 0, -4. So I could actually graph that. There's my point. And then if I want to make a straight line, if I want to make a linear relation, I need at least 2 points. So I can count the slope. Rise of 1, up 1, over 5, 1, 2, 3, 4, 5. Up and over. Okay? And then get out your ruler, get out a straight edge or whatever, and connect those 2 lines. And then I put arrows on both sides. Okay? So whatever form of equation I give you is going to tell you something. There's going to be information. In this case, it told me the slope and it told me the intercept. All right, what else did we look at? Okay, graph x plus 2y minus 8 equals 0. So the wording of this is all wrong. This should say maybe convert. Okay, I have x plus 2y minus 8 equals 0. That is general form. Beautiful way to write a final answer, not super useful. Okay, and this is something we're going to do quite a bit. I don't want it in in general form. I'm going to convert it to slope-intercept. So I'm going to rearrange to get the y all on its own. Maybe I start by subtracting x from both sides. That gets rid of the x beside the y. 2y minus 8 equals -x. We'll now get rid of that constant. Add 8 to both sides. 2y equals -x plus 8. And now I can get rid of the coefficient, divide by 2. What I do to one side, I do to the other. -x over 2. Well, there's a coefficient of 1, it's negative 1x. So as a fraction, negative 1/2 x. 8 divided by 2 is 4. Okay, so there it is. I've converted it now to slope-intercept, which tells me, hey, your slope is negative 1/2, and your b value equals 4, or that's a y-intercept of 0, 4. So I can plot that y-intercept. It's the exact same thing we just did, and then use your slope. Negative 1 over 2, rise over run, down 1, run 2. Down 1, run 2, there's a point. I could keep going. Down 1, run 2, there's another point. I could go the other way, up 1, back 2. And I could make all these points. And then I'm going to connect them with a straight line and pop some arrows on it. Okay, so whenever I give you something in general form, doesn't mean it needs to stay in general form. I needed to graph this. I needed the slope and y-intercept. So I converted it to slope y-intercept, and then I was ready to roll. So just because information is given one way doesn't mean I need to use it that way. All right. Next ones. Determine the equations of the lines below. Okay, it says equation of a line with a slope of 2/5 and passing through the point 1, negative 2. Well, there are 3 equations of the line. They're on my formula sheet that you should be using on that assessment tomorrow as well. Slope y-intercept, we just looked at that one. Okay, general form, that's kind of the nice one. And then I also have slope point, which is y take away a y value equals the slope times x take away an x value. And that one works when I have the slope and any point. I don't specifically need the y-intercept anymore. Let's call this point x1, y1. And then I have the slope. And I can plug directly into that formula. Y, take away y1. Subtract negative 2 would actually be plus 2 equals the slope of 2/5 times x take away your x value, which is 1. Okay, that is an equation of the line. And then you might say, okay, well, it said your answer is supposed to be in slope-intercept form, and this is slope-point form. Fine. I'm not worried about that because I can always start with any form of the equation and then change it to whatever I need. So I don't want this, so I'm going to get rid of the brackets. Y plus 2 equals 2/5 x minus 1. Okay, I want the y all on its own. Add 2. Sorry, no, that's not 1. That's 2/5. 1 times 2/5. Okay, add 2, add 2. And I'm kind of running out of space. Y equals 2/5 x. Negative 2/5 plus 2. Let's say I don't want to do that. Go to your calculator, bracket. Negative 2 divided by 5 plus 2. 1.6. Well, I already have a fraction, so let's write that as a fraction. Math, enter, enter. 8/5 plus 8/5. There you go. Okay. So finding an equation, I need slope and a point, and then I can go right to slope point form, and then I can make it look however I want. Okay. Next one, this is a doozy. Determine the equation in general form of a line through -3, 7 and to -8. Well, what this relies on is finding slope, because I have a point, right? I actually have 2 of them. Let's call it x1, y1, x2, y2. I have, okay, those 2 points. So for slope point form, I can pick either one of them as my point. What I don't have is slope. So what I'm going to say is I know the slope formula, which again is on your formula sheet. You don't have to memorize. I've already labeled my point, so it's easier. Y2 minus y1, -8 minus 7 over 2 minus -3. Okay. -8 minus 7 is -15. 2 minus -3 is 6. And there's my slope. I can reduce it. Both of those numbers are divisible by 3. And you get -5/2. Okay, so there's my slope. And now I need to pick one of my points. Okay, so I'm going to say, here's 1 point, here's my slope. I could pick the other one, but I'm not going to. And here's where I'm going to go. Okay, this is y minus y1 equals m times x minus x1. Plug it into slope point form. It says I want it in general. I don't care. Okay, I'm going to start in slope point and then work back that direction. Y minus 7 equals negative 5 halves times x plus 3 minus negative 3 would be plus 3. Okay, and now I got to start rearranging. Distributive property, get rid of those brackets. Let's start cleaning up the mess. Negative 5 halves x minus 15 over 2. Okay, I need to move everything to one side. So I'm going to do that. I'm going to say, okay, plus 5 halves x. Let's move that over. If I did that on one side, I have to do it on the other. 5 halves x plus y minus 7 equals negative 15 over 2. Get everything equal to 0. Get everything on the other side. I'm going to add 15 halves. And then I'm going to have to add that to the constant over here. Okay. And I'm totally out of space, so I'm going to work backwards, which I hate doing, but that's okay. 5 halves x plus y. Negative 7 plus 15 over 2. Okay. Negative 7 plus 15 divided by 2, if I don't want to do it by hand. 0.5, well, let's write it as a fraction. 1/2. Yeah, probably could have converted that one without my calculator. Okay, equals 0. So, in terms of general form, I need everything on one side equal to 0. Done. I need the x to have a positive coefficient. Done. And I cannot have fractions or decimals. Not done. So what I'm going to say is, I have a divide by 2. That's the fraction I'm looking at. If I wanted to get rid of that, the opposite of divide by 2 is multiply by 2. What I do to one side, I do to the other. I have to do it to the entire left side and the entire right side. So it's like I'm doing the distributive property. Okay, and I get 5x plus 2y plus 2 times 1/2, 1. Oh, hey, I got rid of that fraction as well. And there it is in general form. Okay, so that's a doozy of a question. I needed to use the slope formula, then I needed to go to slope point form, and then I needed to do a pretty tough conversion to general form, but ultimately I'm able to do it. All right, so that would be both of those questions, determining the equation of the line, keeping in mind I need to find slope somehow, and I need to find a point, okay? And depending what I'm given, I can do it in different ways. All right, number 5, the slope of a segment passing through. I'm not going to do this question because we kind of just did. Just remembering this formula. I label my 1 point x1, y1, your second point x2, y2. You plug into the formula, you're good to go. You need to be able to find slope, right? I'll give you a question that just says, find the slope between these 2 points. And that's it. It won't be any bigger than that. It won't be any harder. Okay. 6 and 7. What kind of line has an undefined slope? Okay. That was a vertical line. What kind of slope or line has a 0 slope? Not a very good line, but horizontal. Okay. A horizontal line. And that was because for a vertical, you have rise over run equals rise divided by 0. I don't run anything. If I'm just going straight up, and dividing by 0 is impossible. We cannot divide by 0. That's why it's undefined. Whereas horizontal, rise over run, you have 0 rise over your run. Well, 0 divided by anything is 0. Okay, so remembering, undefined slope, that's when it's straight up. 0 slope, that's when it's perfectly flat, horizontal. Right? The slope of a segment is 2. M equals 2. Then the slope of a segment perpendicular, and then the slope of a segment parallel. All right, well, parallel is my favorite thing in the world. A parallel slope is the exact same. Parallel lines have the same slope. They have the equal slope. It is the exact same number. Okay. Perpendicular slopes come from the negative reciprocal. So what I look at is 2. Maybe I write that as a fraction, 2 over 1. The reciprocal means flip your fraction, top to bottom, bottom to top. Okay, and negative meaning, hey, this one was positive, so the new one has to be negative. Your perpendicular slope is the negative reciprocal. Okay, so that's crucial to know. What's a parallel slope? What's a perpendicular slope? I will absolutely ask you something like that. Okay. Okay, there's some questions here I'm going to let you do on your own. I think you're pretty set up for this. And this is the last one I'm going to do. The slope and y-intercept of the line represented by 3x plus 2y plus 12 equals 0 are, and I have to find the slope and y-intercept. Well, you can read the hint, and this is what I'm going to say. This is in general form, so I can ask you for something that's not immediately told. But I can take 3x plus 2y plus 12 equals 0. And I know if that's written as y equals mx plus b, I know the slope and I know the y-intercept. So sometimes when I'm asking you these things, it won't be direct. It won't be right in front. You got to do some rearranging. Okay, move the 3x over, trying to get the y all on its own. 2y plus 12 equals negative 3x. Move the constant over, minus 12, 2y equals negative 3x minus 12. And finally, divide away that coefficient. Divide by 2, divide by 2. Y equals negative 3/2 x, a fraction, minus 6. 12 divided by 2 is 6. So from this, I know the slope. That's the coefficient on x, negative 3/2. And I even know my b value, or my y-intercept. So I know it needs to be negative 3 over 2. I cross off c and d. Those are the wrong slope. It's negative, not positive. And it is not positive 6, it's negative 6. B, that's your answer. Okay. So for similar questions, same thing, right? Maybe I'm giving the information in a different way, and you know that you can rearrange. Okay. So other than that, you've got a few questions to do here to practice up. You can go back and look at some old lessons, and that's it. I'm only going to say due to 23. Everything past that is, I would say, not important for our assessment tomorrow, our assignment tomorrow, and not as important kind of for the unit as a whole. So focus on 1 to 23. We've already done a lot of them together, okay? And then you'll be ready to roll for the assignment tomorrow. And that is it. We are done another unit. That's our review for linear relations. So you'll want to finish those questions. I think just 1 to 23, and then the last couple pages you can skip. And then tomorrow you'll be working on that summative assignment. And then we're done linear relations, and we're getting pretty close to the end of the year here. So as always, make sure you ask lots of questions on this, right? Send them in the Google form, send me some emails, set up a one-on-one. Make sure you're ready for that summative assessment tomorrow. And that is it. Good luck on the assignment. Have a fantastic weekend, and I'll see you guys again on Monday.